Welcome to another RDWorks Learning Lab. Now today I'm going to tackle a subject which I've played with several times before and I've seen so much, I'm going to be rude and say crap, about how to set the beam up on one of these laser machines. Now this session will finish up teaching you exactly how to set a beam up, why you have to set a beam up that way, and it's a complete explanation. So you can choose to ignore it if you wish and just fiddle with the bits and pieces of screws forever and ever and ever and never get your machine set properly. So I'm going to show you how you must go about this task and why you have to go about it in a certain way. But before we do that, I'm going to create something that I'm going to call a beam simulator. It's basically a dummy machine that allows me to show you in great detail how to set the beam up. So the first part of this video is all about creating that beam simulator. Now, if you don't want to create a beam simulator for yourself, then just jump to halfway through. But if you're interested in making something similar for yourself, the drawings will be available on the www.rdworkslab.com website. In this session, we're going to take a look at a problem that somebody asked for my cooperation with a couple of weeks ago. They were trying to design a very simple beam simulation system that would enable teaching of beam alignment without going anywhere near a machine. We've got a laser beam. I'll turn it off and on. And the idea that my correspondent had was a very simple idea. Basically, he wanted to make something out of chewing gum and string. Okay, so I exaggerate slightly. That would enable him to very cheaply show how to set a laser beam. And this is the basic principle that he was working on. And so I took it through to its conclusion to see just how far and how good it could be. Look, the idea is you've got mirror 2 at position 1 and mirror 2 at position 2. So, hey, we've got a pretty good simulation there of the y-axis movement, and we should be able to set up the y-axis using this kit. And then, in addition to that, once we've set up the y-axis, provided we turn this kit round and hang it off the edge of the table, look, we've got a head, which we can plug in here as well. So we can simulate the head being close to mirror number 2 or distant from mirror number 2. And we can set up the z-axis. When I first saw the design, I thought, well, the design is simple, but I could see all sorts of problems with it. So immediately I started working on this design, I ordered a couple of linear rails from China because I felt that the only way to simulate proper beam setting was to use linear rails because of the stability that's required. And by stability, let me just show you. Now, I think you should be able to see the beam in there. But because it's got 0.5 millimeter of clearance in it, it's got diagonal twist motion. And look what the twist motion is doing. It's very difficult to get this thing stable. And of course, then in addition to that, look, you've only got to put a little bit of pressure on here and things start moving in this direction. It's difficult to set it. So you have to physically hold the thing down like this to make it stable, so that you can adjust the beam. And then when we go and send the beam through mirror 1, if we take a look what's happening on mirror 2 now, if I adjust the laser beam, and now look what happens when I adjust mirror 1. So twisting mirror 1, this whole thing is totally unstable. There's no way that you can ever set the beam to a fixed position and be confident that it's there. And of course, it gets even worse when you try and send a reflection off of mirror 2 when it's at its extremity. Okay, now this is not a full simulation of a machine because we have got no gantry moving backwards and forwards. Okay, but we've got enough of a machine here to simulate setting up the path perfectly. But we're never going to do it with this bit of kit. The only thing that was successful about this was this bit here, the laser beam itself. Every sort of laser pointer that you get has got a big beam on it. Yes, you can generally focus the beam down to a small point. But you know what happens when you focus the beam down to a small point? You've produced a conical beam, which means that the beam will be big at mirror number 1, get smaller at mirror number 2, and eventually it'll be a pinpoint down at the work. That makes it very difficult to set mirrors 1, 2 and 3 up because you haven't got a small beam. This very, very cheap diode laser that I've got in here is not very powerful. Look, it runs off a little battery pack. Like all laser beams, it has got a Gaussian intensity distribution. And what does that mean? That means that right at the centre of the laser beam we have maximum intensity, and so consequently we can mask the laser beam and hide it behind a very small hole. And that very small hole means that we've got, look, a little matching pinprick size, very, very visible laser beam. And as I move it further away, and I'm now something in the region of about 2 feet away, it hasn't changed at all. That's how you can exploit the intensity profile of a diode laser. Just use the very intense central part of the beam. Now, after my first attempt, here we are with my pieces, my linear rails that have arrived from China. And I've started to redesign this dummy machine. And you can see that it's now a piece of 3D equipment rather than a flat sheet. And that's necessary to give us total stability, everything nice and solid. So I've manufactured this strange shaped box out of 5mm acrylic, and I've mounted my 2 linear X and Y rails on here. So this is going to be wonderful. I can tell you that before I start. Now, I haven't designed all the other pieces for this yet. I'm going to design them little by little and gradually work my way round the system. So look, even as we go, I've discovered I've got to make a few small design changes. I've got a screw that's going to fix through there, and I don't want the nuts to twist because they're underneath. So what I've got to do is to put a little nut plate underneath there to stop the nuts from twisting. I've got another piece to go on the back there, but I won't put that on for a minute. You'll see what I mean. I want a guide for this thing to slide backwards and forwards. What I really should have done is allowed these 2 tongues here to stand up 1/8 of an inch, project through 1/8 of an inch, and then I had my guide in there for free. Now, I didn't show you how to assemble the main box up because hey, once you've got the pieces in your hand, it'll become obvious how the pieces fit together. The next sets of pieces are slightly more complex, so I will go through the assembly of these with you. If you note with these pieces with their long legs on, 2 of them have got hexagons in them and 2 of them have got holes in them. Well, what we're going to do, we're going to put the hexagon in front of the holes, so we want one of each plate, and on the right hand side you're going to have these 2 square holes, and then we're going to pick up this funny piece here and we're going to pop that in the back, and that plugs through both of those plates like that. And then we've got this one which is exactly the same, hexagon holes in front of the round holes, and then you can pop that into there. I'm using my favourite Petg glue, which is also an acrylic cement, but because it's designed for Petg, it goes off slower. It doesn't cure quite as quickly, and that's great because it means you don't get any cracking along the edges when you glue them, whereas with normal acrylic cement quite often you get stress cracks along the joints. I'm going to pop some glue down these tongues and along the back edge, down these tongues and along the back edge. Now you'll see that it's come through, so if we move that around just a little bit for a few seconds, then the excess glue on the underneath is not there, it's dried. I'm also going to put a blob of glue down these bracket supports. Now I'm also going to run a bead of glue across the top joint here, because I don't want these plates to come apart. There is a possibility that I might have got something wrong when I calculated the height of this. This is made of 10mm thick material to take into account the fact that this bearing plate is 10mm thick, 10mm tall, and I want everything to line up 10mm off the deck. But when I look at this, I think I've made a small error in that when I put my mirror on here, it's probably going to be 3mm too low, because I've got an additional plate on there which is used to fix to the bearing plate. So I may well have to add another 3mm matching plate to the bottom of this. We've just used an ordinary 20mm Phillips head type screw, pan head, and we've got an M3 nut which we'll pull back into the hexagon housing, and we do it the same at the bottom there. Now this is for mirror number 1. This is typical for number 1, 2 and 3 mirror holders themselves, not the frames but the actual things that hold the mirrors, and we're going to assemble them like that. We've got a 35mm M3 screw with a crosshead, pan head. I'm going to poke that through there. Then I'm going to put an M3 nut on the back, and the M3 nut will disappear inside the hexagon on the back plate. Just tighten up the screw so the nut is actually only jamming the screw on the front plate. When you put the back plate on, it actually locates on the nut. So we need to make sure that when you tighten that up, it's tightened up nice and square and even. So we'll hold it by this back bottom corner by the screw, and then we'll put some glue in 2 or 3 places around there, and that will, by capillary action, that would migrate between the plates. And then we can push the plates together, and we'll do this, just press it to make sure it's flat for about 30 seconds, and then we can just hold it together and squeeze it. You only need 2 adjusting screws to swing this mirror around. That one is just a pivot point, and so I've set that pivot point to a fixed position, and that will leave a gap of about 1.5mm. When we plug this through here like this, there's a hole in the bottom there into which that pin fits like that, and it acts as a pivot now for the mirror. And then we put a spring on there and an M3 nut, and then I can just tighten up the nut. So we've tightened that spring up in there so that we've got about 2 or 3mm of movement left on that spring. Okay, now we can tighten up these 2 screws on the back here. Now those screws drop into little pockets, and as we tighten these screws up, we get movement this way, which is basically directing the beam up and down by adjusting the top one. So as you can see, when I adjust the top one, what happens is this fixed pivot and this screw act like hinge, and they cause this plate to move like that. And then when I want to move the beam from left to right, I'll adjust this one, because this one moves the plate like that because it's pivoted between there and that screw. So we've changed the hinge from that direction to that direction, so we get nice clean motion. We don't get any. If you have a triangular system, you get strange motion. Now you'll notice also that I've managed to get this mirror working with just 1 spring, strategically put into the right place I might add, but it's only 1 spring that's required to make this mirror system work. I've now got to manufacture some 25mm acrylic mirrors, nice and cheap, to fit into this system. I have got some molybdenum mirrors, but molybdenum mirrors will change the setup of the system, because molybdenum mirrors will reflect off the front face of the mirror, whereas this mirror is sitting right at the back here and reflects 3mm deeper. Now that might not sound a lot, but it'll make a big difference to the way in which the system sets up. We've got to make sure that the laser pointer is a snug fit in this hole here, and it is too snug at the moment because I've purposely made that about 0.1mm undersized to what it needs to be. So here I've got a 6mm drill, and I'm basically going to use that like a reamer, and I'm just going to put that through there. Look, you can see how easy it went through, but I've got to rotate it several times to take just a little teeny weeny bit of material out of there. And hopefully that should be enough material removed to allow me to slide, not slide, but I've got to force. Now make sure we put it in the right way round. So the grey piece goes on the front. There's a little teeny weeny hole up there at around about 10 o'clock, and that matches up on the centre of that hole there. So again, we've got our screw to go through there, which will help line everything up. But before we do that, we've got to do two things. First of all, we must make sure that we put this through here to start with. Otherwise we're going to be in trouble. And then that should, if I'm lucky, and I might have to use my electrical pliers, which have got a nice curve in the end there, just to hold on to part of that and give it a twist and a push. And there we are, that's nearly flush with the front of the hole now. So what we'll do, we'll just put this piece of black plastic on, this piece of opaque plastic on, which is important for that hole. So again, we need to line these up before we lock this screw up. And again, we're going to put glue down between these plates. And that should be sufficiently loose that it almost comes out the bottom. We'll just turn it over and put a little bit in the bottom. Okay. Now we do that same trick that we did before. Make sure you keep your fingers dry, otherwise they'll stick. We keep the edges nice and square. Pop the nut into its pocket. And we'll pop that screw right through. Put a spring on the back. So we just set the plate up square. Although that's not the right target, you can see that the centre line should be about here somewhere, and we can adjust it left and right onto centre nice and smoothly. Now, one of the important aspects that I haven't spoken about yet, but I will when we come to setting it up, is the reason why I've got the lacer and mirror one on the same plate. They're not separate, they're together, because you've just seen me set the beam up onto mirror one, and look, no matter where I move the lacer beam, it's always in the middle of mirror one. You can't do that with any of the lacer machines that you've bought, I can guarantee that. Okay, so I've added my extra 3mm plate on the bottom there, and I've got to put this guide plate on the corner here. And I think what I'd do is just something like that, hold it against the edge, which is where I know it's got to go, and I'll try and clamp it in that position. Make sure there's none on the outside. Just make sure I push it up against it tight. So that's really just a reference edge to keep this in a straight line, and you'll understand why I'm doing that at a later date. I've also made some 3mm acrylic mirrors. So there we go, my target just sits in there, and regardless of how I move this around, the target doesn't change. Now I've got an additional hole in here that passes right the way through, and I'll drop a screw into there because that represents the nominal setup position for the mirror. Well, I have to say things are going quite well so far, because look, I've got my parallel here, and my target is, my lacer beam is virtually in the centre of the target. So I've only got the smallest amount of adjustment to do on here to get it set right on the spot on the centre of the target. But what we have to remember is that this beam is not hitting the surface of the mirror. This beam is hitting the back surface of the mirror. So it's not actually hitting the centre of the mirror as that target indicates. If it was a surface mounted mirror, it would be hitting the centre of the mirror. Now this is the frame for mirror 2. It's virtually exactly the same as everything else, except it's on a different base plate with 4 fixing holes on it to fix onto the bearing. So we then clamp it down while it dries, and look, we make sure we don't stick it to the plywood. We'll move it around a few times, and again make sure everything is nice and square and uniform. Now we can poke the mirror through the hole and locate the mirror on its pivot point at the front corner here, if you remember. We need a spring and an M3 nut. So parallel gap there, and we're ready to assemble. Now we're going to stick the mirrors in with a piece of strong double-sided tape. Well, that's not going to come out, double-sided tape, but if I wanted to, I've got a hole through the back there so I can actually push the whole thing out. This is only 3mm thick. The hole in the bearing is about 3, maybe 4mm thick. So really I could do with an M3 by 6 long. Well, I haven't got that. I've got this 8mm long thread. So what I'm going to do is to put a washer and a crinkle washer underneath it, and that should take up the difference. Oh yes, perfect. That's nice and snug. It's a great feeling when a plan comes together. Look at that. These are the pieces for the head. These are the pieces for the head mounting bracket, and these pieces you'll recognise here are for the mirror that goes on the head. So I think we might start off by mounting the mirror on this centre head piece. So if you remember, we have the hexagon holes in front of the plain holes, and we need the squares down the right hand side. Then we can pop this in the back like that, and then that sits on there. So get my piece of anti-stick material out, piece of plywood, and we put some glue down the edge of the bracket and along the front and the back of the plate. And while we're here, we may as well stick some glue down between the plates as well. Okay, now we can try and hold the whole thing together. Just move it around to make sure there's no glue underneath that's sticking. Okay, so now we can build the rest of the head. And the sensible way to do this is to pick this piece up, put it on its side. So put these two pieces to the top, like that, both the same way. Okay, so that's fairly stable. And then we can pop this side piece on. There is only one way for this to go, a square corner at the top here. All the others have got a round edge, a soft edge on them. That's the head assembled and it's completely stable now. So we'll carefully rotate it onto its front like that. And then we can hold this between the tongues. Don't put your finger on the tongue because you'll get them stuck. This back edge and this front edge. Then we can hold the whole thing together for around about 30 seconds. And now it's reasonably stable. Okay, so what we can do now is we can pop glue round the top faces of these side pieces. 1, 2, 3, 1, 2, 3. There we go, that's done. Those tongues pass through the slots like that, and then this piece lays on the back. Put the tongues upwards and it'll sit all flat on the back then, and we need to drop some glue into these 4 tongues, and you'll see that the glue will actually run between the plates as well. Something I haven't done, I've just noticed. I should have countersunk these holes here, and if we've got that right, that should fit on there. and give us nice vertical adjustment in Z. And then I find this is a difficult task to get this backing off, but I generally find that a pair of tweezers is one of the best things for lifting it off with. Like that. Okay. And there we go. That's never going to come out. I've now countersunk these holes, and in a minute I'll go and mount that onto the bearing block. We're nearly there now. We've got to put the screw and the nut through those holes. Spring and a nut to hold it on with. Some M3 by 12 millimeter countersunk screws. Hopefully they should be the right size to pass through here. Now maybe they're too long. I'll go and grind a couple of millimeters off the end of these screws. So we just fix our mounting plate. So we've got one more job to do. Taking a 25 millimeter long screw, and I'm winding a nut on, and then we'll pass that through that hole there, and we'll put another nut on the other side. Okay, now those two nuts, they form a solid end stop for this slide. You'll see the reason for having an adjustable Y, because all I've got on the head here is an adjustable Z. Whereas in the previous design, which we had, which was this one, remember, which plugged onto the top, what we had an adjustable Y and an adjustable Z built into this bracket. Well, I'm pretty happy with that. It all feels lovely, no slop in it at all. So that's a very good simulation of a machine. Not a complete machine, but enough to show and demonstrate how to set a beam accurately. Now, I've created these targets, and unlike normal targets, these are not going to get thrown away because we've got no laser burning our target. That little square reference in the centre there is marked out in 1 millimeter squares. And remember, the beam itself is about 1 millimeter diameter. So we should be able to get an idea pretty accurately of where the beam is at each end of the stroke. Well, before we go anywhere near the simulator, we need to understand what it is that we're trying to achieve. Now, I have to admit that I was guilty of all sorts of misdemeanours about lenses when I first started playing with these laser machines. My ignorance was immense, and it's only gradually decreased with time. So I'm going to give you guys a flying start. The first thing we must say is that a lens is manufactured with something called spherical geometry. Now, look, that means that it is part of a sphere. And a sphere has an axis about which it pivots and rotates. And look, that axis passes right through the lens. So that is the axis of the lens. It is the axis that would pass through the centre of the sphere if the rest of the sphere was there. But we're only going to use this part at the top here as the lens. Here is what we are trying to achieve with our beam setup. The laser beam hitting mirror number 3 and bouncing downwards so that it passes right through the axis of the lens. Now the lens works because it has parallel rays of light hitting this curved surface, and those parallel rays of light get refracted off that curved surface in various degrees to come down to something called a focal point, which is just here. That is perfection. It is very, very difficult to achieve that condition because the Chinese don't make it easy with the design of their machines to allow you to achieve that setting. I'm not saying it's impossible, I'm just saying it's close to impossible. Now, the most likely situation that you're going to encounter is that your beam hits the mirror at somewhere other than the sweet spot. Now, the sweet spot is that point on the mirror which will reflect the beam perfectly downwards and through the axis of the lens. As you can see in this case, we've hit another spot which is not the sweet spot, and we're not passing through the central axis of the lens. Now, look, I've just drawn a single line for my beam, but as I said, the beam is this wide, but this is effectively the path of the most intense part of the beam. And it's the intense part of the beam that does damage to material. So if we follow this beam, you'll see that it is not passing through the axis of the lens, and it is actually being refracted towards the focal point, because all parallel rays will pass through the lens and get refracted to this focal point. But hey, look, this is the most powerful part of the beam, and it's going to pass through the focal point at an angle. That means that your cut is going to be at an angle, because this is the most powerful cutting part of the beam. This part here is relatively unimportant, and this bit here, well, it's missed the lens altogether, and it's probably heating up the inside of your lens tube. Now here we've got another potential situation that happens, and that is that the beam may not be coming in absolutely true, although it's running through the centre of the lens at the contact point. Although these rays are still coming in parallel, they're not coming in at the correct angle to the face of the lens. They're not parallel with the axis of the lens. And because they're not parallel with the axis of the lens, they will fly off at an angle like this, and they will miss the focal point. So A, you'll probably find yourself hitting the inside of your nozzle if you've got a small hole nozzle. And secondly, look, the most powerful rays are also running off at an angle. So again, there's another reason why you'll produce an angled cut on the edge of your material. So these are the two things that we're trying to overcome and ignore. This is what we're after. This is setting perfection. If you get the beam passing through the central axis of the lens, it will pass through the centre of your nozzle as well. You must not attempt to set the beam up through the centre of the nozzle. You must attempt to set the beam up through the axis of the lens. Checking that it passes through the centre of the nozzle is just a check. It's not a setting point. Okay, now here is a point that I was very ignorant of when I first started setting beams up. This is mirror number 1, and here is the laser tube up here firing the beam at mirror number 1. I believed that probably the best way to set was to make sure that my tube or my beam was running absolutely parallel with my gantry. Rubbish. It turns out that it doesn't matter what angle you set your tube at. Wherever you fire the beam at mirror 1 has the ability to rotate and be set so that you can, even this beam here, which is incorrectly firing at mirror 1, you can rotate mirror 1 and make it come out in this angle. So it doesn't matter how you set the tube up. The only thing that's important about setting mirror number 1 up is that the beam should hit the centre of the mirror to give you the maximum scope of use of the mirror. Let me explain. You will probably have a 20, probably a 25mm mirror. Part of that will be masked by the frame, so you may well only have as much as 23mm clear mirror. But when you fire the laser beam at it at 45 degrees, this is what the laser beam sees. It sees 23mm top to bottom, but from side to side that is round about 13 or 14mm. So we've got to be reasonably accurate left to right when we come to set up our beam. And the ideal situation is to set the beam at mirror 1 right in the centre. But if it's at 1 or 2mm high or low, as you can see, it isn't really going to affect anything. So don't get too anal about getting it perfectly on the centre of the mirror. Lots of people believe that is the only place to set the beam. Wrong. You have some flexibility north and south when you set mirror number 1. If you follow this through to mirror number 2, it's exactly the same picture. So you've got flexibility north and south for mirror number 2. But of course when we get to mirror number 3, the situation is reversed. We've got a lot more horizontal flexibility at mirror 3 and not much vertical. But on the other hand, as I just described to you when I spoke about lenses, there is something on this mirror called a sweet spot. You might nominally be aiming for the centre of the mirror when you set the beam up in this general direction. But what we're really interested in is making sure the beam hits the so-called sweet spot that's on that mirror. So let's take a look at the first axis that we're trying to align, which is the y-axis down the side of the machine. The beam comes in, bounces off of mirror 1, and ideally it passes along this line here, which is absolutely parallel and true to this white block here, which is the bearing rail. And that's the aim of the exercise. We've got to get that beam running true to the axis bearing rail. And as you can see, here I've got absolute perfection. I'm bouncing off of mirror 1 and I'm passing through mirror number 2 on its center point, both here when it's close to mirror number 1 and here when it's furthest away from mirror number 1. So that's what A and B are. They're the true positions for mirror 2. What chance have we got of doing that? Well, it's a pretty difficult task that people just do not seem to understand. And let me explain why it's not a simple task. It's a very tedious task that depends on a process of something called iteration, which means you don't get it right first time. You get it a little bit better than it was before, and then you try again, and you get a little bit better again, and you try it again, and again, and again. That's what iteration is. And that's what we're going to show you here, how important that process of iteration is to setting the beam up. You're not going to set a beam up in one hit. For the purpose of this exercise, I'm going to move my mirror 1 out of position. That's where I had it set for perfection, and I'm now going to move it out of position. And this could easily be your machine. You don't know the relative positions of mirror 1 and mirror 2. Hopefully the Chinese have managed to get them reasonably close together, but you can't be sure. So let's tackle it from this position. Okay, the beam comes in, bounces off mirror 1 and reflects right down at the end of the stroke. Now this is not beam alignment, so we have to adjust mirror 1 so that our beam at least appears on mirror 2 at its extreme position. Okay, so we've got a target on here, and we've probably just burnt a little mark on the target. And when we move back to the beginning here, we'll put a clean target on here, and we will burn a mark. Now if you look very closely, you'll see that I have simulated a little burn mark on there with a circle. So that little burn mark there at A is what I will call the target mark. So when we move A to position B, and there's the target mark there, what we've now got to do, we've got to adjust mirror 1 so that the beam hits the target mark. Let's look what's happened to the beam at position A. So although we've moved this target mark to position B and we've hit the target at position B, because we've adjusted the mirror, look, it's no longer on the target mark. We've created a new mark here. We'll move the mirror back to position A, we'll put a new target on, and we'll create a new target mark. Then we move from position A to position B, and look, our target is not matching the beam. We have to make the beam hit our target. But hang about, we've already been around this loop once, because by adjusting mirror 1, we've moved it away from the target mark. Bring the mirror back to position A, take a new target, and we have to burn another target mark. And when we move that target mark to position B, look, it misses. So now we've got to adjust the beam to hit this target. As I've already seen, as soon as we adjust the beam onto the target at position B, look what we've done at position A. We've missed the target again. We have not got the beam passing through the same point at A and B. So we've got to create yet another target. And we go through exactly the same process again and again and again, and eventually we get to this point where we're getting a bit fed up. And we still haven't got it right. Look, there's my final attempt. And I'm going to say, damn, I've run out of patience. But look, I've run out of patience, but I still haven't got absolute perfection between position A and position B, which means that my beam is not perfectly aligned to the axis. It's very nearly aligned to the axis, but not perfectly. And that can have an effect later on, the fact that we haven't got that beam running exactly parallel to the axis. But you get the idea. Look, it's taking me 1, 2, 3, 4, 5, 6 attempts to get that beam parallel to the axis. I can't cheat. It's taking me 6. If you can get it done in 2, it means, well, you're nearly there. But trust me, you can see that even with 6 attempts, I have not got perfection. You can't see that degree of imperfection with a burnt beam. It's very, very difficult to see that degree of perfection. So the chances are that after 3, maybe 4, possibly, you will think, I've now got perfection. I've demonstrated to you that 6, 7, 8 times and you will still not have perfection. You've got near perfection at 3 or 4 attempts. So this process of iteration is a very important point for you to remember when you're setting up your beam. Patience, patience, patience. Now, that process that I've just described there is from mirror 1 along the y-axis. This could equally well be mirror 2, and this could be the x-axis. This could equally well be mirror 3, and this could be the z-axis. It doesn't matter what axis you're working on. This process of iteration is exactly the same for every axis. Okay, so here we've got our beam simulator. Laser tube out here with a beam coming out hitting mirror number 1. Mirror number 2 moves backwards and forwards as per a machine, and mirror number 3 moves as per a machine. Although there's no gantry on here, this is a simulate position for the end of the gantry. So we should be able to simulate setting the beam up, passing through all 3 mirrors and finishing up at this point here, which is the axis of the lens. I'm not going to be able to get that perfection that I've just described to you, that theoretical perfection that allows me to go 5, 6, 7 or 8 times to get the perfect beam. We're going to find it after maybe 3, maybe 4 attempts. And that's about as much as we can go. And we just have to accept the fact that there is going to be a degree of imperfection in our settings. Now, the first thing that I must state is I've removed the acrylic mirrors because they were starting to become a bit of a nuisance when I did a quick experimental test. Bouncing off the back of the mirror is completely different to bouncing off the front face of these molybdenum mirrors that I've got in here now. So I've had to go for the real thing in the end. Real bearings, real mirrors. So we've got a pretty good real simulation. As you can probably see there, look, it's switching the laser tube on and off. You'll see that this screw is not only the fixing for the spring on the back, but I'm using it as a location for the target as well. And I'm locating off the bottom edge here to keep everything nice and true and square. There it is. Now, it's not in the centre. So, remember the way in which the laser beam works. If I go to the top, I should be able to make it go up and down. And I can do. So let's put that onto centre line. And now we go to the bottom one, and that moves it left to right. And I can move it left to right, as you can see. So let's put that on centre as well. So there we go. That's nice and easy. I mean, you can't do that as easily with your beam, but that's what you've got to ideally achieve. So now we bounce the beam off of mirror 1 onto mirror number 2. We've got our target there and it's way off. So let's move it to position B And you can see that the beam is way off the centre of the target. What we'll do, we'll set that so that it goes onto the centre of the target, like that. Okay, job done. Or is it? Let's move back to position A, and you'll see that job is not done. We're nowhere near parallel. Okay, so what we've got to do now is to say, well, look, if that is our target, and it's way off, but if that is our target, let's just try and make a note of where it is. Look, it's just above, it's about on the end of the crosshair, and it's just a single dot, maybe 1 millimeter above the crosshair. So it's about 1 millimeter off the end of the crosshair and 1 millimeter above the end of the crosshair at position A. Now I mustn't change that because that's my target. So we now move to position B, and of course it's way off target. What we've got to do now is to move this beam about 1 millimeter above the crosshair and 1 millimeter beyond the crosshair, about there. But let's have a look what happens when we bring it back to position A. Well, we're now about 3 millimeters off of our target. That's our new target, so you've got to remember that. 1 millimeter high and 3 millimeters wide. So we're okay height wise, but width wise we've got to go to about 3 millimeters, which is about there. And that looks to be about right. So after 3 attempts, we've managed to get that about parallel, i.e. the target at A and the target at B are the same. Even though we know that they're not, but within the scope of what we can see, they appear to be the same. Big problem. We're not on the centre of mirror number 2. How can we deal with that problem? You cannot fiddle with these screws at mirror number 1. You've just used those screws at mirror number 1 to set the beam parallel to the axis. You can't ignore that and just twist those screws to make your beam come to the centre. It's not going to work. So that's another very important lesson. There are 2 parts to aligning a beam with a mirror. Number 1, align the beam parallel with the axis, and then you have to make a physical, mechanical adjustment to the mirror to put the beam onto the centre of the mirror. You cannot steer the beam onto the centre of the mirror. You've got to physically catch the beam by adjusting the mirror itself. In my case, the way that I've got my machine set up, because I thought about this a long time ago, about how to best set a machine up, and I haven't yet seen any or many Chinese machines that adopt this process. I can loosen my screws off, and let's remove this nominal fixing screw, and this is why I want this reference edge along here, because I can now move this beam backwards and forwards like this. And hey, can you see the miraculous effect that it's having on the position of the beam as it hits mirror number 2? So I can now very accurately set onto the centre of mirror 2. Hopefully, because I've made this a parallel motion along here, I will not have affected the settings on mirror number 2. So technically we can see there that it's 1 millimeter high. I have made a slight difference. Because the beam was so far out here to start with, I was guessing where 3 millimeters was. I didn't have an accurate assessment. So now I've got the beam back into the centre again. So I'm 1 line high and half a square to the right. I'm 1 line high and half a square to the right. The important thing here is that it's parallel, and it's approximately in the centre of the mirror. Okay, so now you are looking up at mirror number 3, and here we are at closest to mirror number 2. So let's first of all make sure that the beam hits the target at its furthermost point. I must make sure that I keep my number 2 mirror jammed against its end stop, and to do that what I'm going to do, I'm going to cheat slightly. And I'm going to keep it against its end stop with a very powerful magnet on the rail. So I'm going to push that on there, and that will keep that locked onto the end stop. There's our target furthest away from mirror number 2. And we could really do with adjusting it so that it's nominally on centre. That may or may not be the sweet spot. We're not interested in getting the beam to the centre of the mirror here. We're more interested in making sure that the beam is running parallel to the x-axis. So we've moved our target close to mirror number 2 now. Our laser beam is arriving at one line to the right and one line above. So we've got to tickle that very slightly to make it one line above and one line to the right. Then we'll check it again. That's pretty well lined up now. We've got it approximately right in the x-axis, but it's not spot on centre line, and it's not spot on centre line in the y-axis either. But let's not worry about that. We'll deal with that at the next stage. The key point here is that we've got the beam running true to the x-axis. Okay, so I'm now going to plug my target, the same target, into this position here. Now hopefully you can see the red dot on there. It happens to be 2 squares to the front and 1 square to the left of the centre line. Now if we've got our x-axis set up correctly, then theoretically it should remain in this position here. As I move closer to the mirror number 2, the dot is 1 square to the left and 2 squares to the front. So there we go. We've proved now that we've got our beam set correct to the x-axis. But now we can see that the beam is not correct relative to this z-axis. So here we are close to mirror number 3, and as I said, we're 2 forward and 1 to the left. The beam is in the middle of that square. So let's move that from the top to the bottom. The beam is a long way off. Exactly the same axis process. Close in, distant, close in, distant, close in, distant. So we've now got to match our target, remember, which was 2 forward and 1 to the left. So 2 forward, 1 to the left. Let's put it on top again. We're now 1.5 forward and on centre line. Down to the bottom again, on centre line and 1.5 forward. Check. Check on the top, on centre line, close to 1 forward. We'll just tweak that again, and that's 1 forward and on centre line. We've now achieved the beam passing parallel to the axis of the lens. It's not on the axis of the lens because the beam is not passing through the crosshair. The problem is, how do we get that onto the crosshair? Again, this is something that you will not have on your machine, but you really want it on your machine, because the only way that you can achieve that perfection is to go all the way back to your laser beam and start fiddling. Let me just loosen the laser beam off, and you'll see that, look, I can move the beam by adjusting the laser tube. But hey, that's a nightmare, because as soon as you start adjusting your laser tube, you'll start adjusting everything else that you've just set up. So you've got to go all the way around the houses again to try and get the perfection that you're looking for. Well, we've got 2 ways of correcting that error that's on there. First of all, we've got to move it in that direction there, which is a Y direction. I pointed out to you before that I'd made my Y axis adjustable. So it's very easy for me to now adjust my Y axis to get rid of the error. I've made my Y axis accurately adjustable. So I've got rid of the Y error. As it happens, it's pretty good in the other axis, which is, if you like, the x-axis. But if it wasn't, then I've got another form of adjustment, two adjusting screws which allow me to adjust the height, the up-down, the z-axis position of the head. As I move the head up and down, I can move the position of the beam. So as you can see, I can adjust the height of that to bring the x-axis onto centre line. And then, as you can see at the bottom position, the beam is passing right through the crosshair. So we've set this up now so that the beam is passing down here and passing cleanly through the axis of the lens, which will get an upright cut. With all the modifications that I've made to my machines, like linking the laser tube and mirror 1 together on a base frame, making the Y adjustable relative to the head, and making the head adjustable up and down. So I catch the beam on this mirror, I catch the beam on this mirror. I don't try to steer the beam by fiddling around with the laser beam. My machines have been like this for the past 5 or 6 years because I found out a long time ago that the Chinese design was just unworkable. I notice as time has gone on, there are 1 or 2 machines out there now that have got adjustable Zs. And there may be 1 or 2 that have linked their tubes and mirror 1 together. This is a rarity. So you will find that your machine is probably, let me be crude and say, an arsehole to set up. But you understand the principles now, and you may wish to go forward and modify your machine to deal with some of the issues that I've demonstrated in this very interesting little setup. It's served its purpose extremely well, even though it can't do everything that a machine can do. It's demonstrated to an nth degree how you have to set your machine up. So thank you for your time, and good luck with your beam setting.